In this circuit, I need to find the current I0 that flows through the 8 ohms resistance, or we can say the current that comes out of the voltage source basically. So this is a very simple circuit. We have just two resistances here, 3 ohms and 6 ohms. The parallel combination of these two has to be calculated, and then that one will be in series with the 8 ohms resistance, as simple as that. So we have 10 volts here, and then we have 8 ohms there, and the parallel combination that will be, since 3 ohms and 6 ohms, the equivalent parallel value will be 3 times 6 over 3 plus 6, that is 18 over 9, that's 2 ohms. So we have 10 volts over 8 plus 2 ohms, that is 10 ohms. So I0 will be 10 over 10, that is 1 amps. So that's there. Now I will do a equivalent resistance problem in this video as well. So here we have a circuit where all the resistances value are 5, and we need to find the equivalent resistance as seen from here. That means when we say as seen from here, that means across this terminal, if a source is connected, what is the resistance that the source will experience? That is the resistance seen from here. So we have to start from this side, from the right, and we can see that these 5 ohms and this 5 ohms, these two are coming in series, and then that series combination will be in parallel with that 5 ohms. So if I redraw the circuit, we will have this much, 5 ohms, 5 ohms, 5 ohms, and then we will have 5 ohms here as well. Sorry, we will have the combination here, because this part will be this is 5 ohms, 5 ohms, and then here we will have the combination, which is 10 ohms, series combination basically. So what I can do is, now these two resistances parallel combination value has to be calculated. So I will erase this part and just replace it with just one resistance, the parallel equivalent. That value will be, since 5 and 10, so 5 times 10, I hope I wrote 10 because these two are in series, so the combination will be 10. So 10 ohms and 5 ohms in parallel. I am not sure whether I wrote that correctly. So anyway, 5 times 10 over 5 plus 10, that's 15. And this one, when we put in calculator, we get 3.3333. It goes on, so I will just put a dash on top, so like that. And then we have this 5 ohms, this 5 ohms, and this 5 ohms and this 3.33 ohms, these two come in parallel, in series. So the series combination will be 8.33, so 33 as a dash as well. So 5 ohms here, 5 ohms here, and this is the resistance that we see. Now again, this I will use a different color, maybe, I don't know. So this 5 ohms and this one, these two come in parallel, and the equivalent value is 5 times 8.3333 goes on, repeated decimal basically. So, and this one is 13.3333, repeating 3333. So the equivalent value is 8.125, sorry, 3.125. I don't know, that's 3.125, and this is 8 ohms, 5 ohms. So now we have the equivalent resistance as seen from here will be just the series value of series of 5 ohms and 3.125 ohms resistance. So the equivalent will be, of course, 3.125 plus 5, and that value will be, our equivalent will be 8.125 ohms. So that will be the equivalent resistance as seen from here basically.